just revising of the Wester's class. Wester's class, we have seen about one of the important concept, that is Maxwell's second equation. So by which gives the relation between electric field intensity and electric potential. Okay, so it gives the relation between electric field intensity as well as the potential, and we have related these two parameters by using the del operator, and finally we have got the expression. So that is E is equal to minus del of V. Okay, so which is the Maxwell's second equation. And in today's class, we are going to see the next concept. The next concept, that is dipole. We are going to learn about the dipole, the basic definition of dipole. Next, after seeing the basic definition of what do you mean by dipole, we are going to learn about finding of electric potential for the dipole. So this concept is also very much important, equally important. So finding of electric potential for a dipole, and next after that we are going to see about torque due to dipole. So this is also important. You don't think that whatever the concept I am telling, it is equally important. Sir is telling all the topics are important. So as I told before that while preparing a unit, you should not leave any concept. So under each concept, we are having subtopics. Each subtopic is equally important. So we don't know from which subtopic they are going to give the question. Okay. So in some semester, in one semester examination, they have given electric potential due to dipole, and in some other semester examination, they have given torque due to dipole. So that is the reason why I am telling. So all the concepts are equally important. Okay, so as of now, we are going to see about the first. We are going to see about dipole. What do you mean by a dipole, and what is the basic definition of a dipole? So here, dipole. So that means di in the sense it is two. Pole means polarity. So dipole. That means if you are going to have two polarity in the sense we are having two polarities, that is positive as well as negative. Okay. Now, what do you mean by dipole means? If you are going to take 2-point charges, okay. So if you are going to take 2-point charges, let it be plus Q and minus Q. So this is positive, I mean plus point charge and minus point charge, positive point charge as well as a negative point charge. If these 2-point charges, if they have been separated by a distance d, then this altogether is called as a dipole. This altogether is called as a dipole. Simply to say, so dipole means two-point charges of opposite polarities. That is plus Q and minus Q, separated by a distance. Okay, separated by a distance d, forming a dipole. So they are forming a dipole. So plus Q charge and minus Q charge, if they are separated by a distance d, then this is called as a dipole. So this is for in the case of electrostatics. Similarly, when it comes to the magnetostatics, one north pole and one south pole, if they are separated by a distance d, altogether this is called as a magnetic dipole. Magnetic dipole. So here this is a electric dipole and this is a magnetic dipole. So about the magnetic dipole we will see in the case of magnetostatics. And now we are going to see about what? Since we are learning under the electrostatics, we will see about electric dipole. We are going to learn about electric dipole. Okay, so now after the basic definition of electric dipole, we are going to see the definition of dipole moment, which is represented by small p. Dipole moment. So dipole moment is nothing but the product of the charge. Okay, so the product of the charge and the distance. So that means a dipole, if it is having plus q and separated by a distance of d. So what do you mean by what do you mean by dipole moment? P is equal to the charge of the dipole, that is nothing but q, and the distance of the dipole, which is nothing but the d. So if you do the product between q and d, so which is called as what? Dipole moment. So dipole moment is equal to charge multiplied by the distance. So which is represented by small p. Okay, so small p. So these two definitions of dipole as well as a dipole moment. Okay, so they are important for short type of answers. Short answers. Okay, so that is for 2 marks. They will ask what do you mean by a dipole or what do you mean by a dipole moment. Then you have to write the required answer. Okay. Now we are going into the next concept. So that is electric potential due to a dipole. Electric potential due to a dipole. So you can have a star mark for this. They are going to have for essay type of answer. Okay. Now we will see the arrangement for the dipole. Okay, and later we are going to obtain the required expression for electric potential due to the dipole. So we are going to take the dipole and we are going to place the dipole along z-axis. Okay, so we are going to place the dipole along z-axis such that the midpoint. Okay, so the midpoint of the dipole will be at origin. Okay, so this is the arrangement. Midpoint in the sense, so here earlier I have taken plus q and minus q, both are separated by a distance d. So what is the midpoint means? This is the midpoint. So from here to here we will have d by 2, and from here to here we will have d by 2. Okay, so such kind of arrangement I'm going to take on z-axis. I'm going to place this dipole on z-axis and we are going to draw the required diagram. So see here, I'm going to have two different colors for plus q and minus q. Okay, so first I'm going to have plus point charge and negative point charge. So this is plus q and minus q. And these two point charges, they have separated by a distance d. Okay, so by a distance d and placed on z-axis. So this is the z-axis such that the midpoint of the dipole will be at origin. So this is the origin, x-axis, and this is y-axis, and this is our z-axis. And since this is our origin, earlier the plus q and minus q both are separated by a distance d, and if this is the value of d, and now from here to here that value will become d by 2, and from here to here this value will become d by 2. So therefore the total distance is nothing but d. The total distance is nothing but d. Okay, so now our intention is what? So our intention is to obtain electric field electric potential at a point P. Okay, so we are going to consider one point P, and at this point P we have to calculate the potential because of this dipole. Okay, so because of this dipole, so let it be, this is the point A and this is the point B, and at these 2 points because we are having plus q and minus q charge, and because of this dipole we have selected one point P, and we have to obtain electric potential at this point P, which is nothing but V suffix P. V suffix P. Okay, so now we are going with the diagram again. So this point P, which is at a distance of R A from plus Q, which is at a distance of R A from plus Q, and the same point P, which is at a distance of R B from minus Q, and next and from the origin, the point P is at a distance of small r. So this is the required arrangement for finding of electric potential due to a dipole at the point P. Okay, so now we are going to proceed with the derivation, but before that, see here, earlier I have already discussed about finding of electric potential. See here, VB and VA. So VA, it is nothing but the potential of at point A, so due to Q, so which is nothing but the formula we have given, VA is equal to Q divided by 4 pi epsilon naught RA. And similarly at point B, so at point B, due to Q, we have got this expression, that is VB is equal to Q divided by 4 pi epsilon naught RB. So now we are going to apply the same concept for our derivation. So see here you have Q, and because of this Q we are going to calculate V. We are going to calculate VP at point P, and again because of this minus Q, we are going to calculate at a point P, that is V. So individually I'm going to write for VA and VB, but at point P, so the potential is because of both the point charges, that is plus Q and minus Q. So therefore at point P, what will be the value? VP will be equal to VA plus of VB. So because VA plus of VB, which is nothing but all together, it is called as a dipole. Okay, all together we are going to got for the dipole. So what about VA? So at A you are having plus Q charge, and at B you are having minus Q charge. Okay, you are having minus Q charge. So therefore individually I will write the expression for VA and as well as for VB. So at VA you are having plus Q charge. So therefore the value is Q divided by 4 pi epsilon naught RA. So this is the distance. So here at A, from A to P, the distance is RA. So therefore I have written VA is equal to Q divided by 4 pi epsilon naught RA. Next, what about VB? So VB is because of minus Q point charge. So therefore here you have to write a small modification, that is minus Q divided by, so 4 pi epsilon naught RB. So Q, it is at a distance of RB to the point P. So therefore I have written VB is equal to what? So minus Q divided by 4 pi epsilon naught RB. And now at point P, so we have to write VP, which is equal to VA plus of VB. So what is VA? So VA is Q divided by, so 4 pi epsilon naught RA plus of minus Q divided by, so 4 pi epsilon naught RB. So what will be the value? So if I take Q as common, so Q divided by, so 4 pi epsilon naught 1 by RA minus of 1 by RB. 1 by RA minus of RB. Okay, so now proceeding further. So this is it. So this is equal to, so take the product of LCM, so Q divided by, so 4 pi epsilon naught. So that value will become, LCM is RA, RB, and the denominator will become RB minus of RA. RB minus of RA, which is nothing but the potential at point P. So we are going to take this as what? Equation 1. Equation 1. Okay. So this is about equation 1. Now we are going with the next case. That is not the case, but here we are extending the above concept, extending. So extending the above concept. So that is what we are going to extend means. So we are taking the point P at infinity. So that means that is a point, the location of point is at infinity. So if the point is at infinity, we have to make some modifications for the diagram that we have done. So if the point P is at infinity, so we cannot see that point P, and accordingly we have to make the modifications for this diagram. So I am making that diagram again in the downward. So earlier we have point charge plus Q, and we have point charge of minus Q, and these 2 point charges, they are separated by a distance D. Okay, so and which is placed on Z axis, So midpoint placed at origin. So this is X axis, Y axis as well as Z axis. Midpoint, it is placed on origin. So therefore this becomes a D by 2 as well as D by 2. Now what is the modification we are going to do means, so see here, so P is at infinity. So if P is at infinity, since we cannot see that point P, whatever the distance is there, so that goes up to infinity. So this is RA, it is going towards infinity, as well as at point B, this is also, so this is B and this is A. That thing also, it is going towards infinity, and the midpoint, that is R, it is also going towards infinity. Since P, we cannot see the point P at P point, so we are extending these lines, the distance vector lines towards infinity. So this is the modification for the previous diagram. And now what you are going to do, okay, we are going to have one perpendicular bisector, but before going into the perpendicular bisector, we are going to talk with respect to the distance vector, that is RA, RB and RA. As P is tending towards infinity, so all the lines they are going towards the infinity. Whatever the distance, that is RA, will be approximately equal to RB, will be equal to R. Since all are tending towards all are moving towards infinity, we can relate or we can equate them such that I am writing what RA is equally is approximately equal to RB, and RB is approximately equal to R. Okay, and now coming towards the diagram, now I am going to draw one perpendicular bisector to from point A to the point towards this point. Okay, so this is the perpendicular bisector and it is making an angle of 90 here. Earlier it is 90. A small modification, I mean small one more adding, I am adding one more point to the previous diagram. So here, if this R is making an angle of theta, okay, so if R is making an angle of theta, so if this is theta and now this is theta here. It is theta. Okay, see here, three parallel lines are there. So three parallel lines are there. So if this is making an angle of theta, obviously this will make an angle of theta and this is also making an angle of theta. So if this is the value of theta and whatever the here, this is also making an angle of theta. Okay, so see, observe the diagram carefully. Now I am going to obtain some equations from the diagram. See here, now I want this distance. I want this distance. So see here, it is forming one right angle triangle. It is forming one right angle triangle from A. This is one right angle triangle. It is forming one right angle triangle. So in this right angle triangle, okay, so in this right angle triangle, hypotenuse is D. We know this distance, hypotenuse, that is D. And I want the adjacent side value. So that from here to here, it is RB. And from here to here, it is RA. And now I want this value, that is nothing but what, RB minus of RA. So whatever the highest value is there, so this is RB and we are going to subtract the value of RA so that you will get this value. So this value is nothing but what? So RB minus of RA. So in this triangle, so whatever the triangle we are having, so this is the right angle triangle. Okay, so here you are having D and just now I have obtained this value, that is RB minus of RA. Okay, and this is the angle made by theta and this is the right angle triangle. So why we are going to find the value, this thing means because see here in the above equation, so we have this value, that is what, RB minus RA, RB minus of RA. Now I am going to substitute the value of RB minus RA, which I am going to obtain from this right angle triangle. Okay, so from this right angle triangle. So from the above right angle triangle, from this above right angle triangle, so what will be the value of cos theta? So cos theta is equal to what? So adjacent side is RB minus RA. What is hypotenuse? Hypotenuse is D. So cos theta is equal to RB minus RA divided by D. So therefore, so cos theta is equal to RB minus RA divided by D. So from this, what will be the value of RB minus RA? So that value is equal to D cos theta. So which is our equation number 2. So substituting, so equation 2 in equation 1. Okay, so substituting equation 2 in equation 1. What is our equation 1? Vp is equal to, so Vp is equal to, so Q divided by 4 pi epsilon naught RB minus RA divided by RA. Now what is RB minus RA? So that is equal to Q divided by, so 4 pi epsilon naught. What is RB minus RA? RB minus RA is D cos theta. So therefore D cos theta divided by, see here, I have made an approximation here. What is that approximation? Since the point P is at infinity, we are approximating RA, RB to what? R. And here, since RA is approximately equal to RB as approximately equal to R, what will be the value of RB multiplied by R? So that value can be equal to what? R square. Okay, so can be equal to R square. So therefore, whatever the value here it is there, RA into RB, here I am writing as R square. So therefore, Vp is equal to Qd cos theta whole divided by, so 4 pi epsilon naught r square, r square. Next step, proceeding further. See here, from the definition of dipole moment. So dipole moment, what is dipole moment? P is equal to Q into D. So in the above expression, we are having this term, that is nothing but what? Q into D. We are going to replace the value of Q into D with what? Small p. So that is, so Vp is equal to P multiplied by cos theta whole divided by, so 4 pi epsilon naught into r square. So this P is different, this P is different. Okay. So this P is nothing but what? The location where we are finding the potential due to dipole. So this P is small p. Okay. So small p is nothing but what? Dipole moment. Small p. Okay. Dipole moment. Next, here recollecting one concept. Okay, so I'm going to recollect the concept of dot product. So dot product is nothing but, so a bar dot b bar. How we are going to find the value of a bar dot b bar? That is equal to modulus of a bar modulus of b bar cos angle between a and b. So this is the basic formula for dot product that we have already done many times in the classroom. So that is a bar dot b bar is equal to modulus of a bar modulus of b bar and cos. So if you observe the above, if you see the above expression, that is in the numerator we have p term and we have cos term, cos of theta. So if you want to express in the form of a bar dot b bar, so here this theta is nothing but what? Angle. This theta is nothing but the angle of these two vectors. That is, here you are having P. If you want to express in form of a bar dot b bar, so what should be the value of theta? This theta should be the angle between P and one more parameter or one more vector. So what is that vector? So if you want to go and observe this diagram, okay, so observe this diagram. So what is theta? So theta is nothing but what? Angle made by this dipole, with the parameter. This is nothing but what? Our r. So theta is the angle between the dipole and the r. So therefore, here if you want to write what is the value of the, what is the theta? Theta is nothing but the angle. So here I am writing separately. So theta. So theta is angle between what? So dipole and r. So dipole is nothing but, here we are going to call r dipole or dipole moment. So that is P and r. So therefore, see here the above expression I am going to rewrite, that is V suffix p is equal to P cos theta divided by, so 4 by epsilon naught r square. Here I can write P as modulus of P, and I have to write, just wait. So can I write this term as, so P multiplied by 1 multiplied by cos theta divided by 4 by epsilon naught r square. Again you will get the same value. So there is no modification, just multiplying by 1. So this is equal to, we know that magnitude of unit vector is always 1. So is always 1. So therefore we have to write here modulus of P, modulus of one unit vector of cos theta divided by, so 4 pi epsilon naught r square. But this unit vector, what should be this unit vector? So see here. So theta. So for theta here, it should be the angle between A and B. Here you are going to take P, and what is B? That is nothing but R. So now we have to express this R with respect to unit vector. So what is the unit vector of R? That is nothing but A R bar. So if you take the modulus of A R bar, that value is equal to what? That value is 1. So therefore, if you want to express this term, whatever the term, here it is there. If you want to write in the form of A bar dot B bar, so since you are having cos theta, and if you want to express with respect to A bar dot B bar, okay, so for that I am writing here P multiplied by 1 multiplied by cos theta. So we know that the magnitude of unit vector is always equal to 1, and theta is the angle between what? P and R. So therefore we have to express R with respect to what? Its unit vector, that is AR bar. So here in place of unit vector, now I can write it as what? AR bar. So therefore Vp is equal to modulus of P and modulus of AR bar, modulus of P bar, modulus of AR bar, cos theta, which is angle between P and R, whole divided by, so 4 pi epsilon naught R square. So therefore now I can rewrite this above expression by using A bar dot B bar formula. So if this is A bar and this is B bar, and cos angle between A and B, okay, so cos angle between A and B, I can write it as what? P bar dot AR bar. So P bar dot AR bar whole divided by, so 4 pi epsilon naught R square. 4 divided by 4 pi epsilon naught R square. Again, say here, from the definition of unit vector. So how to define a unit vector? So if it is a AR bar, so that value is R bar by modulus of R bar. So earlier we have written, so A bar is equal to A bar by modulus of A bar. So this is the basic formula. So applying this unit vector formula on R vector, so that value will become what? AR bar is equal to R bar by modulus of R bar. So now I am going to substitute the value of AR bar in this expression. So therefore the value, the above expression will become Vp is equal to, so P bar dot R bar, so divided by 4 pi epsilon naught R square modulus of R bar. So see here, so this is the magnitude and as well as this is the magnitude. So finally we can multiply them directly. So Vb is equal to, so P bar dot R bar whole divided by 4 pi epsilon naught R cube. So which is the final expression. So this is the, so electric potential due to dipole at P, which is at infinity, which is at infinity. Okay, so Vb is equal to P bar dot R bar divided by 4 pi epsilon naught R square. Okay, so don't worry. So since I'm going to share this video again, okay, so watch the video multiple number of times until you get clarity with the concept. So still if you feel any doubts, don't worry. So you can ask me so that I can make clarifications wherever you are having the doubt. One of the important point is, if you understand the diagram, whatever the diagram here we have drawn, okay, so earlier for you have to, in the examination you have to draw both the diagrams. Okay, so earlier we have considered the point P, which is at infinity, it is located at point P, and later we have gone with the derivation. So Vp is equal to Q divided by 4 pi epsilon naught Rb minus Ra divided by Ra Rb. So this is at point P. Now we are considering, we are extending this concept. That is what, if the point P is at infinity, if the point P is at infinity, then we have made some the necessary modifications for the above diagram, and here we have drawn the diagram. Okay, and proceeded further by taking, since we need the value, of RB minus RA, since we need the value of RB minus RA, we have got the value of RB minus RA from where we have got, so from the right angle triangle. From this right angle triangle, we have got the value of cos theta, that is RB minus RA divided by B, and we have substituted the value here and applied the concept of dipole moment, that is P is equal to QD, and again expressed the above expression by using the dot product concept as well as the unit vector concept, and finally obtain the expression, that is Vp, that is equal to P bar dot R bar divided by 4 pi epsilon naught into R cube, which is what the electric potential due to dipole at point P, which is at infinity, Okay, so this is all about this dipole. In next coming class, we are going to see about electric potential due to dipole. Not electric potential, sorry. Electric field intensity. Okay. So electric field intensity due to dipole, and later we are going to calculate, we are going to obtain the equation of torque due to dipole. So finding of electric field intensity due to dipole is very much easy, since we have the relation between electric field intensity and electric potential, that is what? So E is equal to minus del of V. Already we have find the value of V, that is P bar dot R bar, or we will use this value, that is QD divided by cos theta whole divided by 4 pi epsilon naught R square, and we will substitute the value of V here and apply the del operator on this above equation, and finally we will get the value of E. So this is very easy by using Maxwell's second equation. And next we have to go with torque due to dipole. Okay.